First of all, I wanted to tell you guys about the introduction. Lemon juice is widely known for its high acidity, which contributes to its sour taste and numerous culinary and medical uses. The primary acid present in lemon juice is citric acid, which accounts for the majority of its acidity. Determining the acidity of lemon juice is important for various applications, including food science, nutrition, and quality control in the food industry. The acidity can be quantified by measuring the pH level and the concentration of citric acid through titration method. And now, we are moving to the theory. There are three theories in our presentation. The first one is acidity and pH. Acidity in aqueous solution is commonly measured using the pH scale, which ranges from 0 to 14. The pH value is the logarithmic measure of the hydrogen ion concentration, which is H+, in the solution. The formula is pH equal to negative log times H+. Lemon juice typically has a pH range of 2 to 3, indicating its high acidity. The second one is citric acid in lemon juice. Citric acid is a weak organic acid that can donate 3 protons H+, making it triprotic. The total acidity of lemon juice can be determined by quantifying the concentration of citric acid, which is usually done using titration. Theoretical percentage citric acid in concentrated lemon juice is equal to 5%. The last one for theory is the titration method. For determining the acidity of lemon juice, an acid-based titration is commonly employed. The concentration of citric acid in the lemon juice can be calculated using the following formula, which is M acid times V acid equal to M base times V base. Next, which is the apparatus that we use. The first one is lemons. Next, the bottled lemon juice, straining gauze, NaOH solution 1M, sodium hydrogen sulfate powder, phenolphthalein indicator, distilled water, electronic scales, retort stand and clamp, 2 250 ml beakers, 50 ml burette, 200 ml volumetric flask, 250 ml conical flask, 25 ml pipette, and the last one is glass funnel.
Before we titrate the bottled lemon juice, we have to do the standardization of sodium hydroxide. So here's the methodology. First, we need to determine the mass of sodium hydrogen sulfate needed to prepare 200 ml of 1M solution. After the calculation, I found that the mass we needed is 24 gram. So then, we need to weigh the 24 gram of N8HSO4 and transfer into 200 ml volumetric flask, and then add the 100 ml distilled water into the flask and swirl until dissolved. And then dilute up to the calibration mark. Measure over 25 ml sodium hydrogen sulfate solution using pipette and transfer to 250 ml conical flask. Add a few drops of phenolphthalein indicator, and then fill 50 ml of burette with sodium hydroxide solution and titrate the sodium hydrogen solution with sodium hydroxide solution until the indicator turns red and record the burette reading. Lastly, we have to repeat step 5 to 8 3 times. Next are the titration of bottled lemon juice. First step, we have to strain the bottled lemon juice if necessary, and then measure over 25 ml lemon juice and transfer into 250 ml of conical flask using a pipette, and then add 75 ml of distilled water into the flask. Add few drops of phenolphthalein and fill the 50 ml burette with sodium hydroxide solution. Titrate the lemon juice with sodium hydroxide solution until the indicator turns red and record the burette reading. Repeat step 2 into 6 3 times. Here's the example of result for our titration. The first standardization titration, there are 4 titration. We calculate the average volume of sodium hydroxide and we got over 22.7 ml. For the bottled lemon juice titration, the average volume of sodium hydroxide is 18.3 ml. To calculate the percentage of citric acid in bottled lemon juice, Based on our titration result, first we have to calculate the molarity of the titration, which is sodium hydroxide. To do this, first find the balance equation of the reaction between sodium hydroxide and sodium hydrogen sulfate by using the formula MAVA over MBVV equal to A over B. We can determine the molarity of the base, which is the NB. The volume of titrant, VB, use the average volume of NaOH in the standardization titration. After calculation, the molarity of sodium hydroxide is 1.10 mol per liter. After that, we can proceed to calculate the mass of citric acid, but first find the balance equation between citric acid and NaOH. Firstly, with the molarity of NaOH, we just calculate. We need to find the mass of NaOH by multiplying the molarity with the average volume of NaOH from the bottle lemon juice titration. The mole of NaOH is 0.02013 mol. Since 1 mol of citric acid is equal to 3 mol of sodium hydroxide, we can simply divide the mole of NaOH with 3 to determine the moles of citric acid, which is 0.00671 mol. From here, we can calculate the mass of citric acid by multiply the moles with molar mass of citric acid. The mass of citric acid in this titration is 1.29 grams. After finding the mass of citric acid, now we have to calculate the percentage of the citric acid by using the formula weight over volume of sample times 100. The volume of the sample is equivalent to the volume of the lemon juice pipette into the volumetric flux in the procedure, which is 25 ml. The percentage of citric acid is 5.60%. Theoretically, the percentage of citric acid content in bottled lemon juice is 5%. So we can calculate the percentage error based on our result, which is over 3.2%. In this experiment, we managed to determine the percentage of citric acid content in bottled lemon juice by titration process. The percentage of citric acid 5.60 represents that there are roughly over 5.60 citric acid in grams per 100 ml of the bottled lemon juice. With a percentage error of 3.2%, this experiment is a success. However, some improvement can be made. For example, filtering instead of straining the lemon juice to remove all pulp and thus increase the accuracy of the result.
Application: cooking and baking. Knowing the acidity of lemon juice help in balancing flavor in dish like salad, dressing, marinade, sauce, and desserts. And the beverage preparation, acidity level influence the taste of lemon-based beverages such as lemonade, cocktail, and mocktail. And the health and nutrition, consumer may choose lemon juice based on its acidity for digestive health benefit or as a source of vitamin C. And the quality assurance, producer use acidity determination to ensure lemon juice meet quality standard and regulatory requirements. Benefit of acidity determination in lemon juice. Precision in culinary application. Enable chef and home cook to adjust recipe based on desired tartness and flavor balance. Consistency in production. Help food manufacturer maintain consistent product quality and acidity levels. Consumer awareness, empower consumer to make informed choice about lemon juice product based on personal taste, preference, and nutrition. In conclusion, the determination of citric acid in lemon juice is not only a practical necessity, but also enhance both culinary experience and food production practice. Methods such as pH measurement and titration provide reliable way to quantity acidity level, allowing chef, home cooks, and food manufacturers to adjust recipe and ensure consistency in flavor profile. Understanding the acidity of lemon juice also empower consumer to make informed choice based on taste, preference, and dietary consideration. We can determine the acidity of concentrate bottled lemon juice via titration method by calculating the amount of citric acid content in it. Therefore, the percentage of citric acid in bottled lemon juice is 5.16% with a percentage error of 3.2% from theoretical value.